The F-22 Raptor. So lethal it will dominate air combat, 10 out and up.
The F-20 plane. It is a four-point team. It makes their... When we start to talk about in the present, which are the young men and women who serve in all of our military services, this is not a business in which you want to be second best or equal. You've got to dominate.
F-22 team of Lockheed Martin, Boeing, and Pratt & Whitney proudly presents Raptor 01, the Spirit of America.
A relieved Air Force Chief of Staff, General Ronald Fogelman, has fought for the Raptor against a host of critics.
This flight is all very good.
You must be very proud.
We are very proud. We'll be proud when we have that first wing and the second wing.
It's about 20 years younger.
You know, after working on this for 10 years, it's really a thrill to see this come out. I got goosebumps.
Among the guests, employees and engineers from some of the 1,400 companies in 46 states working on the F-22.
Oh, that's beautiful, huh?
The honor and burden of first flight will fall to Chief Test Pilot Paul Metz.
Well, for a test pilot, there are certain benchmarks or certain events that are very important and something you covet. First flight of a new airplane is one of those events. Quite frankly, there are very few first flights nowadays because we don't build that many new airplanes. So it's a rare occurrence in the life of a test pilot. And I happen to be very fortunate to be in a position to make this first flight. So I consider myself extremely fortunate.
Taking a new fighter aircraft up on its first flight is the dream of every test pilot. For months, Metz has practiced every move he'll make. The Gulf War. For the first time since Korea, the U.S. dominated the air. A ground war all over in 100 hours because of a devastating 43-day aerial assault on Iraq. A handful of radar-invisible F-117 Nighthawks destroyed 40% of Iraq's strategic targets. Overhead, F-15 Eagles drove Iraqi jets from the sky. General Richard Hawk, head of Air Combat Command.
Air dominance is an extension of air superiority. You might think of it as total air superiority, which is a basic mission of the United States Air Force. It's the first thing that our warfighters ask the United States Air Force to do in combat, to gain control of the airspace over the battlefield. Air dominance is something that you have achieved when you own the sky over both your side of the battlefield and the enemy's in order to allow your forces to do whatever they need to do to win in combat with the fewest casualties and the least possible collateral damage to enemy forces as you engage them.
The F-15 Eagle is the current U.S. air dominance fighter. It first flew in 1972.
Its first employment came at the midpoint of its life in Desert Storm. It owned the skies in Desert Storm, and we achieved this thing called air dominance because of the capabilities of that airplane and the well-trained air crews that flew it. So we learned to like air dominance. We think this is a pretty good strategy we've developed for structuring our force with a relatively small number of very highly capable air superiority fighters. At some point out there around 2015 to 2020, we are going to have to replace our roughly 200 F-15 interdiction airplanes. They will be old, and they will no longer be able to penetrate those dense threat environments that will occur in that time frame. The F-117 will be tired. It will be well over 30 years old by that time. So we'll have to replace it. We're going to be looking for an airplane to fill those missions. In my opinion, the F-22 will be the airplane of choice. We've designed the F-22 against a threat projected by our Defense Intelligence Agency that will appear in the time frame of about 2010 to 2015. We won't take delivery of the first squadron of operational F-22s until late in the year 2004. And it will be our primary air superiority fighter for the next 30 years.
To replace the F-15 and the F-117, the Air Force set up a competition between Northrop and Lockheed Martin. Each firm built 2 prototypes, then had a fly-off, aircraft pitted against aircraft. Tom Burbidge, project manager for Lockheed Martin.
We each built 2 prototypes. Ours was the YF-22, theirs was the YF-23. And we flew the airplanes in a 90-day fly-off. We each had 2 prototypes, and each prototype had a different engine in it. Pratt & Whitney was selected the winner on the engine, and Lockheed was selected the winner on the airplane. We then went under contract for the current phase, engineering, manufacturing, and development, in August of 1991. And we've been working that contract ever since. We've been designing and developing the airplane. We're now about to fly the first airplane, the first of 9 test airplanes.
All prototypes combine the Nighthawk's stealth with the F-15's combat ability. But the YF-22 proved more maneuverable.
We designed the F-22 to have 4 basic characteristics that we believe are going to be required to achieve air dominance in the next century. Those are maneuverable stealth, a very stealthy signature against all families of radars, and the ability to maneuver as good or better than any of today's fighter aircraft. Second, supercruise. Just as stealth shrinks the ability of enemy radars and missile platforms to detect the airplane, so will supercruise reduce the lethality of the associated missiles. The third major characteristic is integrated avionics. The ability to integrate all the sources of information that today our pilots have to integrate inside their heads. And finally, a large payload. The airplane will carry 8 air-to-air missiles internally, so it will retain its stealthy characteristics. It will be able to outturn, outfight, and deal with any threat in the air or on the ground in that next century that it's designed to work in. It will achieve what we call first look, first shot, first kill.
Raptor test pilot Paul Metz says the F-22 has what's needed for today's aerial battlefield.
If you look at stealth in particular, the ability to move now through that battle environment, unseen, undetected, and unleash your firepower on the enemy. The ability to supercruise, that's the ability to move very quickly across the battlefield, very high speeds. We're talking in this airplane the ability to cruise, sustained cruise at 1,000 to 1,200 miles an hour. This airplane has thrust vectoring. That is not a capability of any past fighter. The ability to stand on its tail and use that thrust vector to push you around at extremely low speeds and still point your nose at the enemy and get a weapon off. And this airplane uses extremely powerful computers. There are 2 of them, about equivalent to 2 Cray-type supercomputers. And what we've been able to do is use the computer now to gather in tremendous amounts of data, sift through that data, and provide the pilot very simple and very intuitive displays that quickly allow him to find, target, shoot, and destroy the enemy before the enemy ever detects him.
For Paul Metz, flying Raptor 01 will be the culmination of a 33-year career.
We train ourselves several ways. We spend hundreds of hours literally in simulators like this one, preparing ourselves in terms of the handling qualities of the airplane as well as how the weapon systems work and working with the engineers to improve those capabilities. We also maintain proficiency. I currently fly the F-15 Eagle to maintain hands-on flying experience with the airplane. I simply go out and maintain my proficiency in high Gs, in maneuvering flight, and in fighter-type activities like air refueling. A more direct relationship, though, occurs in the F-16. There is an aircraft called the Vista, which is a variable in-flight simulator. That aircraft has some unique computers in it that allows it to mimic any other airplane. It can mimic the space shuttle, it can mimic a B-2 bomber, and in our case, we actually programmed that airplane to mimic the F-22. Quite frankly, the simulators we have today have reduced the risk considerably from my forebears who pioneered early flight test work. In addition, I spend a lot of time working with a mission control team, in this case 33 pilots and engineers who work with me, and we go through that first flight, practice it on the ground, and I've flown the first flight using an F-15 in place of the F-22 with my chase pilot and my photo chase pilot to actually replicate that mission. So By the time we're ready to roll this airplane, I should feel very comfortable with what's going to happen. Sitting behind me is Raptor 01. It's the first of the development airplanes, and it's going through a series of checks. Right now, they're doing fuel system checks. We'll be doing structural checks we call ground resonance testing, where we actually shake the airplane and determine if it's structurally as limber and bends the way we had predicted it will. We'll be moving up into taxi tests, where we take the airplane at ever greater speeds down the runway, look at the handling qualities, and then finally, we commit it to the first flight. The test program starts off with 3 aircraft that are what I call engine and airframe. Their basic task is to create the chariot, the vehicle that the pilot will ride in. The 4th airplane and beyond now has the avionics in there, and so what we do is we give the pilot a suite that takes him in a chariot and makes him a charioteer. It's one thing to spend years looking at a piece of paper and the computer simulations. It's quite another thing to have the real pride and joy behind you, and looking forward to that first takeoff.
First flight of the Raptor will take place at Marietta, Georgia, home to Lockheed Martin. If successful, it will move to a legendary airbase where every U.S. fighter since World War II has been put to the test. Like the F-22 prototypes before it, Raptor 01 will undergo rigorous testing over California's Mojave Desert, flying out of Edwards Air Force Base. For 5 years and 2,700 flights, Mets and other test pilots will bring out F-22s before they go into service. Edwards, on the dry sand bed of Rogers Lake, long the proving ground for American jet fighters, a place where aviation history is made and remade. Dr. Jim Young is Edwards' base historian.
If you were to play a word association game with somebody and ask them to come up with a place to match the word flight, more people would probably say Edwards than any other single place. It was here that Mach 1 was broken for the first time, Mach 2, Mach 3, Mach 4, Mach 5, Mach 6. It was here that for the first time man flew above 100,000 feet, 200,000 feet, 300,000 feet, and indeed flew for the first time into space in an airplane.
As early as the 1920s, Southern California aircraft manufacturers discovered the advantages offered by the dry lake bed. John Northrop brought his flying wing prototype to the lake bed, proving the concept for aircraft he would build in the 1940s.
By the early 30s, then Lieutenant Colonel Hap Arnold was looking around for a bombing and gunnery range for his squadrons. And of course, what he saw was the vast 44 square mile expanse, the largest natural aerodrome he'd ever seen. The lake bed, the weather, the isolation, the fact that within easy flying distance of this place you have virtually any kind of terrain you could possibly require, including overseas.
In May 1941, the British ship a Gloucester aircraft to Rogers Dry Lake. It has a gas turbine engine invented by Sir Frank Whittle. The Americans are shocked by the potential of this primitive jet and mount a crash catch-up program. Out of it comes the General Electric 1A jet engine and the first U.S. jet aircraft, the Bell XB-59A Aero Comet. Early jets are slow to accelerate and need long takeoff runs. They have a tendency to flame out in flight and need a lot of room when they have to glide down to a dead stick landing. The lake bed, a gigantic natural land. Edwards was then known as Muroc Gunnery Range, and facilities for aircraft testing were non-existent. Turbojet technology ensures the future of the Rogers Lake base. The Great Lake bed attracts the hottest new aircraft, and they in turn attract the hottest test pilots, risk takers, avidly seeking a moment of truth in the sky. In 1947, an event at Muroc excites the world. As part of a new experimental program, Bell's X-1 makes a series of flights since a valid aerodynamic 50 caliber machine gun bullets the speed of sound on his 9th flight. One of those attracted to this mecca of flight is an expatriate Canadian born at Medicine Hat, Alberta, Captain Glenn Edwards. One of the new breed, he's a pilot with an engineering background. Edwards becomes project pilot on multi-engine aircraft, one of them the YB-49 jet-powered Flying Wing. June 1948. Edwards is testing the aircraft's stability control. It breaks up in midair and crashes, killing Edwards and 4 crew members. The U.S. Air Force renames the base in Edwards' memory, endorsing in the process test pilots with a background in aeronautical engineering. By the mid-50s, pilots at Edwards established the basic flight envelope in terms of speed and altitude of all jet fighters to the present day. They test the first American air superiority jet, the YP-86, forerunner of the F-86 Saberjet that ruled the skies over Korea. It is the only aircraft designed specifically for air dominance until the F-15. The Century series of fighters also arrives in the 50s. From the F-100 Super Sabre up to the F-106 Delta Dart. More like rockets than fighters, bigger, faster, Soviet airspace. In 1960, the F-4 Phantom, a powerful and heavy 2-seater, records. The Marines, Navy, and Air Force will all fly the Phantom in Vietnam, where American air power, with aircraft relying on brute thrust, is in for a surprise. General Richard Hawley.
We learned that a general-purpose airplane like the F-4 that we wound up using predominantly in that war, along with the F-105 and the F-100, were not good enough to be able to own the skies. In Vietnam, we had to fight our way in every day. We lost over 1,200 airplanes from the U.S. Air Force. The U.S. Navy lost over 500. We had hundreds of pilots incarcerated in North Vietnamese POW camps. We don't want to do that again. We don't want to have to fight for air superiority every day as we try to get to our targets. So we learned our lesson and we developed the F-15, a dominant air superiority fighter.
Now retired, Colonel Wendell Shaw was chief test pilot for the F-15.
The F-15 was the first airplane in almost 15 years that was developed from scratch. Now, I think the F-15 was far superior to the F-4. Earlier, the F-4 was kind of the primary air superiority airplane to get out, so the enemy could see them for miles and miles and miles. The missile did, plus the turning performance. The F-4 turns pretty well if you pull in too tight. Airplane can depart, go into a spin, and, you know, about, I guess, for the Air Force, done. And the bottom line was we were trying to, I think, going straight up. It's the first airplane ever built that had a greater than 1-to-1 thrust ratio. And the way the airplane, it was designed to turn, not to go fast. I was very amazed at how well it flew. I thought I was not going to survive because they wanted a 5G accelerating turn. So you start very slow and keep accelerating at 5Gs. And so here I was going round and around trying to accelerate at 5Gs. The 5Gs isn't bad for the body to sustain, but to hold it for several minutes, that's a lot. Probably the biggest improvement that wasn't obvious externally was the electronic warfare capability. And now the pilot has an actual display that says you are within range and you're within the envelope and you know when to fire the missiles. I believe up until right now, there's no airplane in the world that can beat the F-15. The F-22 obviously will in several years when they finally get it developed and get out there to the Air Combat Command.
25 years after Wendell Shaw worked up the F-15 at Edwards, the excitement is building for Paul Metz and his K-2. Supporters say the F-22 is not just another new fighter, but an explosive, revolutionary leap in technology. The greatest challenge confronting the designers of the F-22, to create a 62-foot-long aircraft invisible to radar and infrared scanners, an arcane technology known as stealth. It involves everything from the shape of the pilot's helmet to the jet's exhaust.
Stealth technology is one of those really unique characteristics. It's not quite the Klingon cloaking device, but it's very, very close to it. You can see in the background the airplane, and you can get a size comparison with the men working on it. Stealth technology allows that airplane size to be reduced somewhere between a bumblebee and a small bird in terms of being seen by radar and other types of sensors.
Well, stealth has really gone through a number of generational changes like any other technology, but very high, very fast. Most of its survivability was due to those two features, but it also had low radar cross-section. The next technology leap in stealth was really with the F-117. With that airplane, we had learned a lot more about the ability to take an airplane and bring it down in altitude and down in speed and operate in what we call the mid-altitude sanctuary, make that a safe place to operate. The 117 scientists invented a way to deal with radar through the use of faceted surfaces and some special technologies in the area of materials. The next generation of stealth was considered the B-2 era, where we were able to go to rounded surfaces and more aerodynamic shaping in terms of the wing. We then come to the F-22. At this point in time, we're able to significantly reduce the impact of stealth on the qualities, aerodynamic qualities that you want to see in a fully maneuverable fighter. And it's really driven by the ability to calculate the very complex algorithms that control both physics phenomena and integrate those in a much more capable manner.
The prototype YF-22 proved the inherent stealthiness of the design, but it will be even more refined in the years ahead. And that capacity to sneak unseen into battle will be integrated into the fighter's striking power with elaborate avionics. The F-22 has already flown 1 million combat missions by computer.
The F-22 pilot has a number of liquid crystal displays available to him, and they tell him various things about the attack environment. On my left, we have a defensive display. These circles represent the surface-to-air missile sites. Stay outside of those rings, and the F-22 can work its way through this threat environment without ever being detected. Let me turn the airplane from an F-22 into an F-15, which would have a much larger radar cross-section. When we do that, watch the size of the circles.
Sam launch.
The F-15, no way of penetrating that threat at this time. I don't like the way the situation's developing, so let me turn myself back into the F-22 and just slip right on by these guys. Let's take a look here at the middle display, my situational display. If I take the cursor and place it over that blue symbol, I get information transmitted to me about my wingman. He has 6 AMRAAM missiles, 2 Sidewinders, and 500 rounds of 20mm ammunition. Also tells me that he's at 12,100 pounds of internal fuel. All of that information is transmitted to me in my aircraft by data link with no request or no radio communications on either of our parts. What you see now in the center display is we've started to pick up, or the sensors have started to pick, they have been identified by the sensors as enemies, and they're always identified as red triangles. We can place that cursor over the red triangles, and we can find out what the computers know about this enemy. He's a 0.8 Mach. I'm going to pick these 4 and shoot him. You might also notice that the other 4 aircraft have a light blue dash line around them. Those are the 4 aircraft my wingman has chosen to attack. What's so powerful about this display is that between us we have a limited number of weapons. Yet every weapon is going to target one and only one aircraft. We do not simultaneously waste weapons on the same aircraft. As we move in, the computer determines we've got a shoot solution. If we look over on this display, the attack display, we can see that, yes, the computer directs us to shoot at this time. What that's telling us is that first aircraft is within range, and your weapon will reach it. So I'm going to go ahead and launch against the first off, flies out. Go ahead and step to the second target. It says we have a shoot solution on the second target. We'll go ahead and launch the weapon. We'll step to the third target. It says we have a solution on the third target. The weapon's away, and the weapon's away. My wingman's missiles are inbound to his aircraft, and he's about to complete his kills. We'll go down here and see how the enemy pilots are doing. They're enjoying their ride down in their parachutes. Here's one of them now. And there he is. Hope he has a nice day.
Hundreds of high-tech companies are engaged on the F-22 project. The chief partnership is between aerospace giants Lockheed Martin and Boeing, and engine manufacturer Pratt & Whitney. Together, they are building an aircraft that has been described as more complex than the human body. or less. To attain the needed precision, holes are drilled with laser-guided robots. For assembly, components are shipped to Lockheed Martin, lead company on the project and responsible for design.
We've actually got over 40,000 wind tunnel hours on this design now, so we know exactly how the airplane will fly when it eventually gets to the air. We instrument these models heavily, and we measure the pressure fields over the model at various airspeeds and altitude conditions. We can get load patterns and determine exactly how to design the airplane. We know what the flying qualities are like. When we built the prototype, we then took that prototype into the air and measured actual flight loads, and we found out that we could make some improvements to the design, some minor ones. We modified the sweep angle, the leading edge sweep angle on the wing, relaxed it about 3 degrees. We also modified the wing tips. If you look at the plan form of the wing tips, are slightly different on both models. More of a rectangular shape on the actual airplane. So wind tunnel testing is an extremely important part of the program. This is also where we start trading off the conflict between the stealth designer and the aerodynamic designer. We're looking at the basic differences between low observability and sure we'll find any weapons carried outside the airplane. So we've been able to combine, for the first time, aerodynamic performance that's superior to an F-15 with low observable performance that's equivalent to an F-117.
The wings of the airplane are about the same size as the F-15, but the wing area is quite a bit bigger, so we have a very nice wing loading on the airplane. It has movable surfaces here, ailerons and flaperons on the trailing edge, as well as the full leading edge has the maneuvering devices on it. They give the airplane an extremely high lift at slow speeds and lets us maneuver at speeds as low as a Piper Cub. The horizontal tails here are huge. They're almost the same size as the wing of an F-16. And then again, at the slower speeds, they give you tremendous pitch authority. The rudders, again, big, give you nice directional stability, particularly at the supersonic speeds. These are the side weapons bays where we carry the heat seeker AIM-9 missiles, one on each side of the airplane. And just like the main weapons bays down below, these doors close up in flight, so the airplane keeps a very low signature. The F-22 has 2 huge F-119 engines in it. These are the inlets, and they gulp in a lot of air every second to power the airplane. The engines so far have been extremely reliable and very, very smooth. They're finely balanced. You hardly can tell the difference between idle power and full afterburner in the cockpit. Right now they're in maintenance mode, so they're splayed open. Normally they'd be closed, but the secret back here is that the nozzles can move down as well as up to help the airplane pitch.
The F-22's revolutionary Pratt & Whitney F-119 engine was built in West Palm Beach, Florida. The company's project manager, Walt Bilchew.
I would sit back here and say that arguably this is the most advanced fighter engine in the world. The exhaust system is special. It's got a vectoring nozzle on the back which permits what you call pitch vectoring, and basically what it says is, as opposed to the exhaust of an engine coming straight out, this now has the capability to deflect it up and down, providing very rapid movement to the airplane, very rapid agility to the airplane. The idea about being able to supercruise, which means fly supersonically without the use of an afterburner. What that says is you need more thrust. Today's F-15s and F-16s, they started off with an engine, what we call a 25,000-pound thrust class. This engine, the F-119, is a 35,000-pound thrust class. But that's not the key feature. The key feature is, as you go out in high Mach numbers or supersonic flight, this engine provides much, much more thrust than those differences that I've given out to you percentage-wise. The engine can come in and out of this airplane very, very quickly, hour and a half. It's in and it's out, hooked up and ready to go.
Lockheed Martin's Plant Number 6 in Marietta, Georgia is where the pieces of the F-22 come together. 42% of the aircraft by weight is titanium and 24% composites. Lockheed builds the forward fuselage, cockpit, tail wings, and rudders. They are joined to wing sections from Boeing's plant in Seattle and to an aft cockpit section manufactured in Fort Worth, Texas. And so Raptor 01 takes form. The work of 15,000 men and women scattered all over the U.S. It rolls out of the plant for its rendezvous with Paul Metz. One day before the F-22's first flight. Paul Metz is aloft in an F-16 for a final rehearsal with the chase planes that will shadow his flight. Every precaution is taken to reduce risk. Weather conditions must be perfect. If the wind is over 6 knots, Metz will not fly.
We spent a tremendous amount of time practicing emergency procedures. What if this should happen? And the reason you do that is so that, again, you're familiar with even the unknown or the unexpected, so that there are no unexpecteds. Well, sir, that looked pretty good. We control the environment very carefully nowadays. We review things to make sure that you don't have an accident and that you don't lose a pilot. And the airplane itself is an asset that you can't afford to lose either financially or politically. The crossover in front. This first aircraft is one of 9, and it is one of the first 3 aircraft that will basically be configured as an engine and airframe. That is, it will not have the full weapon systems in it, but it will be used to take the airplane to its maximums. Here in Marietta, with the first 3 flights, we're in a relatively confined or small envelope of the airplane's total potential, about 250 knots maximum airspeed.
First flight day, a $78 million program at...
We'd like the mission control room manned about 9:15. We're looking for about a 9:30 engine start.
If we start at 9:30, let's have a check-in at 0945. We'll take off probably about 10 to 10:15. When the time came on Sunday to get ready to fly, there was a very high anticipation level. And I think people sensed that because we'd had a series of very successful taxi tests at ever-increasing speeds, and everybody had the sense that this was going to be it. So anticipation was up.
The ritual walk of the taxi strip to search for bolts and stones that might be drawn into the Raptor's engines takes on a new importance.
And I just want you to know that you're all really special people. You've got a tremendous sense of working together, and so I'm proud of each and every one of you, and I rely heavily on us getting this airplane through the first flight, and we're going to do that today. Well, probably somewhere in the recesses of my brain, there's a little devil back there saying, push the power up, push the power up. You're anxious to see what this airplane will do. It's obviously got a lot more potential in it than what I'll see on the first flight. But I also know that the only way to go about it is very methodically and very carefully.
The initial operating capability of the airplane is set for 2004. So if you go back to the first requirement to fielding, it's 25 years. And if you put it in the context of aviation in general, that's about 1/4 of the time since the Wright brothers flew. So you think about who's going to fly the airplane, you have to think about your kids and your grandkids. 11-year-olds today will be the first group, really, of squadron pilots to fly the airplanes.
All the testing is risky, and what you try to do is you try to minimize the risks. You don't know that the engines are going to operate as predicted. You don't know the airplane's going to handle as predicted. Mother Nature is going to tell us what the real answer is. And so we could have differences in the aerodynamics of the real airplane. The day began just about like any other day. Get up, get ready, and go to work. I had thought about the flight, obviously, for a long time. I felt very comfortable with what was going to happen.
Paul Metz, who has flown 72 different aircraft, sets himself to fly number 73.
When we rehearsed the night before with my mission control team, we ran through the emergency procedures. I began to get a little bit of sweaty palms when I realized we were going to do it. But over the years, in the profession, you actually do learn to turn it off and on like a switch. I was surprised that I was able to get in the airplane, and once I was there, I felt very comfortable. I knew what I was going to do, and turned off the emotional side and just focused on the technical details at hand.
METS controls engines that represent over half a century of jet propulsion technology. They have the power of an entire squadron of F-86 Sabrejets of the Korean War era.
Push the throttles up in this airplane and accelerate, you feel yourself being pushed back in the seat. You obviously don't have that sense in the same with roll and G-loads. And so in that sense, it's interesting and fun to tie in now the physical sensations of the world with all those hours of simulation, which was a purely visual world. And in that sense, the airplane has a character, and you begin to become a part of that character. The absolute raw power is something else. The airplane accelerates tremendously quickly, and in fact can achieve supersonic speeds with well less than military power. And that's something that the pilot's going to have to get used to. He's going to be breaking windows and scaring chickens if he doesn't watch where he places that power just on routine cruising flights. He'll be supersonic before he knows it.
When you look at the future and the role that the United States is going to play in the future, where we're no longer two superpowers kind of controlling the world, you're one superpower trying to maintain stability in the world, you've got to be recognized as having the lethal might that people don't want to challenge.
It's an insurance policy against catastrophe happening someplace around the world. And with the F-22, we'll be able to deal with that catastrophe wherever and whenever it occurs through the first 3 decades of the next century. It will ensure that we can fight future wars with that low level of casualties like we had in Desert Storm.
Come on, pull through it, baby. Get up, get up.
Lie ahead. Thousands of hours of test flights before the Raptor is ready for combat. The first wing of F-22s will not join the U.S. border of battle until the year 2004.
During the flight, I kind of stayed detached from the emotional side. I very distinctly remember coming back and landing, and my crew chief checked over the airplane to make sure there were no leaks, and I asked the taxi back down the runway back towards the crowd. And I think at that time it really struck me, as I looked out on all those people, how many people had made that day possible for me. And it touched me quite a bit. There are thousands of people across the United States. There are people around the world that have contributed pieces and ideas to this airplane. And every one of them is important. Without the individual contribution, this wouldn't happen. tremendous emotional high to doing that. You felt like you'd really accomplished something that's quite unusual, rarely done, and you've had the privilege of being in a position to make it happen.
The F-22 enters the ranks of fighter aircraft, the newest in a long line that reaches back to the earliest days of flight. She is stealthy and swift, with a single overriding mission: air dominance, control of the skies.